Hey everyone, welcome to this How to Create an AI Smart Assistant session. It's wonderful to see so many of you here, a packed house in the Mesquite room, and yeah, seeing lots of familiar faces in the crowd as well. It's been awesome seeing you all come by the expo booth and hearing about all the weird and wonderful things you're doing with Survey123 and Quick Capture. It's been really awesome. So it's lovely to see you all here. My name's Jim Moore. I'm a product engineer on the Survey123 Quick Capture team. And with me is my colleague, Barbara Webster. Barbara, would you like to introduce yourself?
Yep, I'm Barbara. I'm also a product engineer on the Survey123 team based out of Redlands.
Thanks, Barbara. And okay, let's kick it off. A little bit about what we're going to do today. First, we're going to give you an overview of our Smart Assistant features in Survey123. We'll run through that suite of features and give you a bit of a brief demo, just so we know what we're creating models for. Then we'll step through, or rather Barbara will step you through the process for creating an object detection model specifically. We do have tutorials on image classification models, but object detection models is something we get questions on a lot, so we thought that would be a good focus for today's session. And finally, we'll show you how this end result can be used in the field app. Firstly, I just wanted to cover where we're using AI in a few different places in Survey123. We like doing a lot of research, and we're dabbling in a few different areas. And so that includes smart assistants in the field app. That's what the focus of this session is. But we've also got automatic translation in the web and in Connect. The Survey123 assistant in the web designer, which uses generative AI to create a survey form for you from a chat-like conversation. I guess I just wanted to stress that we use this word assistance a lot, but the focus of this session is TensorFlow models for smart assistants in the field app. That's predominantly what we're going to be focusing on. That said, Barbara and I would also like to demo another AI feature that's still in research and development, but we think it's really cool, so we just kind of wanted to give you a sneak peek of it at the end anyway. And anyone who was in the Road Ahead session yesterday morning, you would have seen this already, but we're going to give you a little bit of a sneak peek, so that's just, you know, to kind of tease you along till the end of the session, but it is worth hanging around for because it's very cool. It's not related to smart assistants, but it's a different type of assistant. So smart assistants in Survey123, these leverage machine learning technology to help you collect data more efficiently. The smart assistants in the field app are specifically for image analysis. That's both for photos that you take with the camera, but you can also use it on photos that you browse for existing photos from your device's storage. And the idea with smart assistants is, as the name suggests, they're here to kind of help you by making data collection more efficient. In most cases, like with redaction and smart annotation, users still have the final say. So the manipulations or detections that the model makes, you can still edit those or override them or discard them if you like. A couple of things to note is that all image analysis happens on the device. The processing happens locally. So the features that you'll see in this presentation, they all work offline. And the features discussed in this session are for the field app only. At this stage, they're not supported in the web app. So as I said, smart assistants are based on ML models, and these models are trained to recognize patterns in images and classify these as objects. So the model might detect, for example, a human's face or a particular piece of equipment. And it also records where in the image that object is in the case of object detection. You can then redact that region or bring information into your survey form about that detection, which makes your forms and form logic more powerful. You can perform object detection and image classification in the field app with your own TensorFlow Lite models. Now, TensorFlow Lite is just one of many model formats, but the reason why we implemented this one in Survey123 is because it's optimized for mobile devices specifically. So they're quite lightweight models, and their performance is really good on mobile devices. A TensorFlow Lite model comes in a TF-Lite file that must be stored in the media folder of your survey, along with an EMD file which has the metadata about the model. And you can use the ArcGIS.learn module in the ArcGIS API for Python to create your own models, and that's what Barbara will show you today. So this slide seeks to help clarify the distinction between image classification and object detection. Those quotes are mine, but I kind of think that they help to clarify what each is, what each of these categories are. So an image classification model is trained to recognize multiple classes of images, but the result is the probability of the image representing one of these classes. For example, if you had a model trained to detect fire hydrants, you take an image classification model, you take a photo of a a fire hydrant, you take a photo of a fire hydrant and the model says, hey, this is a photo of a fire hydrant or a photo of a stop sign or whatever it may be. So image classification models are really well suited to applications where there's only one target object in each image and you're doing quite rapid data collection. We have a tutorial on how to create an image classification model, as I mentioned earlier. It takes you through the process of setting up a model that can detect stop signs and speed signs. And there's a QR code at the end of this presentation I'll show you, and you can head straight over to that tutorial. Another great example of an application for image classification is plant species. We had a great sort of test model in the early days where you could take a photo of a plant or a leaf and it would tell you what species that plant was with some degree of, confidence. And that's another application where you want just one definitive answer. This is a photo of a maple tree or what have you. An object detection model is trained to detect the presence and location of multiple classes of objects in an image, and that will be the focus of this presentation. So moving on to the Smart Assistant features that we have in the Survey123 field app. The field app. The first one is Smart Attributes. The objects detected in an image are stored as JSON in the image's EXIF metadata, which you can then extract in the form, and you can use that as the answers in other questions, or you can use it to apply constraints and so on. Here's an example of an object detection result for Smart Attributes, and that's indicative of the JSON that would be stored in the EXIF. You can see that it has the class names, the confidence score, and also the bounding box coordinates of where that detection took place in the image. If this was an image classification model, the array of objects for each individual class would contain only one class, and there also wouldn't be any bounding box coordinates. But effectively, it's very similar. And here's just another example. So that's an object detection. That's the live camera preview in the Survey123 field app. You can see there's a phone, a mouse, and a remote control. And on the right-hand side, you can see how that's represented in the EXIF. So using the pull data at EXIF function, or pull data at JSON rather, in XLS form, you could extract all of those individual bits of attribute data from the JSON and use them however you like. So the second Smart Assistant feature is Smart Redaction, where you can automatically obscure regions of an image to remove things like PII and other sensitive content, even things like text on a screen or maybe signage that you don't want stored in the photo. And you can configure your survey to blur, pixelate, or block out the redacted regions. In addition, we've also put in a redaction editor, which allows you to manually modify the redacted regions, just in case the model doesn't get it quite right. It's worth noting the redaction cannot be reversed, which is what you want, right? You want to redact people's faces or PII or whatever and have that burnt into the image. It's also worth noting too, on iOS and Android only, not Windows, you can use built-in face redaction, which uses the built-in APIs on the device to detect faces and then blur them out or block them out. You don't need a model for that, it just does it straight out of the box, and I'll show you that in a minute. And lastly, we've got smart annotation. So it's kind of a combination of these things, and it allows you to apply annotation like graphics and labels and symbols based on a model's detections. And you can kind of see that in that example there. There's a car and a truck, and those annotations are burned into the image, the bounding boxes and the labels. That's kind of the default behavior, but you can customize this with a custom palette. It really comes into its own. If you're familiar with the annotation tools in Survey123, it uses those existing annotation tools. You can create a custom palette to say, look, if I detect this particular type of object, let's put this type of symbol around it or this particular type of label. Obviously, it helps to reduce the effort required to annotate an image and also reduce the risk of errors. So that's those 3 Smart Assistant features in a nutshell. We have 3 awesome samples in Connect. If you head to the Esri samples section in Connect, there's one for each of those features, and they have models in them as well. So you can start running those on your device straight away, and they come packaged with a TensorFlow Lite model as well. So would encourage you to check those out if you want to play around with this some more. So I'm just going to show you a couple of these things live, and hopefully it'll play nice. I've got Survey123 installed on our iPad here. Hopefully we can get it up and running. Here we go. And the first one I'll show you is smart. Let's go for smart redaction first. Hang on, I might have to turn this around because I think the camera's at the other end. Hopefully we can see it. So this is the smart redaction feature that we just discussed. And I'm going to use, we've got a few different options here, but I'm going to use this one. And if I point it at the crowd, hopefully, it's a test, but we'll see how we go. Oh yes, live demos, here we go. All right, so I've captured the image and you can see it's done a pretty good job. It hasn't got everybody, but I mean, there's a lot of people in this room. And we've had a lot of customers request this kind of functionality because maybe they're doing asset inspections or things out in the street, but they have a requirement to not show, members of the public walking by or whatever. So this is pretty neat because it just does it straight out of the box. It's worth mentioning too, you can combine multiple models. Obviously you'll take a bit of a performance hit, but you could do redaction on top of like other object detections as well on the same image. So now it takes me to this sort of editor mode where each one of these detections I can adjust, right? So I can make the boxes bigger or smaller, I can move them around, I can delete them, I can add new ones. Say it missed, it got my colleague Brett at the back there. So the guy sitting next to him, I can maybe put a box over him, there we go. And maybe another one, we'll move that down there. And then when I'm happy with the redactions, I press save, and then there's our saved image with the redactions. But as I say, you can also configure the type of redaction you want, blurring, pixelating, or you can choose a color to do like a solid block out. Or you can actually use a symbol like an emoji, or if you've got some sort of graphic that you want to put over the top of someone's face as well. Okay, so that's smart redaction, and let's quickly take a look at smart attributes. And again, it's very similar to the screenshots that you saw in the slideshow, but I just, there's nothing better than seeing it working for real. So I've got a phone and a book and a mouse, and you can see it's bringing that up in the live preview. And what I'm using here is a common object detection model. If you download any of those samples from Connect, this is the model that you'll get. It's an open source model that was trained on hundreds of thousands of images, but it detects 80 plus common objects. So, practical use in the field, this model probably isn't useful for many of your own very specific use cases, but it's very cool for demos. And you can see what it's showing me there is the bounding box, but also the confidence score for each of the detections. And I just wanted to show you this because you can see that the object detections here have been wired up to other questions in the survey. So we have object class is detected, it's picked out 3 different types of object, but we've also got a select multiple question there, and it takes those answers and puts them into the to the select multiple to show you what the photo detected. So that's smart attributes and smart redaction, a brief little demo, but the models that these are using, how do you make them? I'm going to hand over to Barbara to answer that question.
Thank you, Jim. Yeah, so in the next section, we'll walk through how to train a custom object detection model and then export a TF-Lite file to use with Survey123. So the model that we'll train today will detect 2 kinds of objects and images, round manholes and square manholes. As I mentioned, this model will be exported as a TF-Lite file, so we'll be able to use the model with a Smart Assistant in Survey123. And the image in the screen is a screen cap of the Survey123 camera while it's configured with a Smart Assistant using this manholes model. So these are the steps that we'll be working through today. We'll gather images of manholes to use for training. We'll apply the bounding boxes and labels to any round or square manholes that appear in those images, and set up the environment in ArcGIS Pro, and then train the model using the ArcGIS Learn module in the ArcGIS API for Python. I'll just add a few notes before working through the workflow. First is that the workflow is also available in a publicly shared story map, which is available through this QR code, or also as a resource link in this session. So as I mentioned, today we're using the ArcGIS Learn module, which can also it can be used to create both the object detection models and image classification models. Today we'll be creating an object detection model, but as Jim mentioned, we also do have a tutorial for creating an image classification model, which I believe we have a link for at the end of the slides. Also, keep in mind that there are several approaches to using the ArcGIS API for Python, such as running notebooks locally with Jupyter Notebooks or ArcGIS Pro, or running notebooks in ArcGIS Online. And there are pros and cons to each of these approaches, which is what we'll take a look at in the next slide. So in notebooks for ArcGIS Online, all of the processing is going to be handled in the cloud. This does require enabling advanced GPU support, and that does also consume credits. Another consideration with this approach is that it will require you to upload all of your training images, and so depending on your workflow, that can easily be a very large upload. Also, currently, there are some additional packages that need to be installed for object detection model training. This is planned to be resolved in the future, but it is an extra step that's currently required for training object detection models with a notebook in ArcGIS Online. A local environment like ArcGIS Pro, on the other hand, which is what we're going to look at today, is run with locally stored training data and does not consume credits. But it will require a device with enough processing power for the model that you're trying to train. One final note is that this approach typically takes a longer time to train because usually the computing resources are a lot more limited than in a cloud environment. So getting back to stepping through the training procedure, we'll start with gathering the training images. So of course, to train an object detection model, you're going to need to gather a large collection of images depicting the objects that you want to detect. There are a lot of variables impacting the number of images needed. For this model, we used around 500 images. There are a few sources for getting your image collection. There are multiple online repositories that offer image collections. Although if you go this route, you will want to double check the licensing and permissions to make sure you're using those images in a way that's permitted. Also, many organizations already have large collections of photos of a specific object. This is a really good source for training data because there are no licensing issues, and the photos are often very relevant to the workflow that you might be using your model in. And then, of course, you always have the option to go out and collect new photos of the objects that you want to train the model on. Relevance is going to be another important consideration while you're gathering your photos. It's not enough to have a collection of photos of manholes if they don't look like the manholes that you're going to want your model to detect. Other factors that you'll want to consider are photo angle. So unless you're always going to be taking photos at a specific angle, like plan view, you're going to want to have a variety of angles. This is true for distance from the object as well. And then you'll want to consider lighting and environment or context. So for example, is the manhole surrounded by concrete or vegetation? And then finally, the class that we'll be using to train the models later is going to require the image to be in JPEG format. So the next step in the process is to label the objects in the images. We'll need this annotation to be in Pascal VOC format, which is a common labeling format for object detection. Again, there are a few options for how to label the images. There are several software options out there. Today, since we have pretty basic labeling needs, we're going to use Label Image, which is an open source labeling software. And I also just included a few guidelines on the slide. You'll want to make sure that you have one label per image and no more than 500 per image. And then the bounding boxes need to be at least 8 by 8 pixels and 100th, or at least 100th the length of the shorter side of the image. All right, so next I'll demo labeling a couple images. All right, so I've created a demo folder here with an images folder that just has a few test images. We also have a labels folder, which is empty at the moment. So if we open up label image and open the directory, we're going to point that to the folder that's containing those two folders, the images and labels folder. We'll also make sure our save directory is pointed towards the labels folder, which it is. And I can go ahead and create a bounding box here. So we'll call this one manhole round. Do another one. Oops. Call this one manhole square, and then we have one more hiding in the back here, which is also manhole square. And if I save this, this is going to be saving a label file in that file directory. So that'll be in the labels folder. This is just an XML file that has the same name as that original image file. And then I can progress through, create annotations for each photo in my photo collection, and then eventually I'll have one label file for each image in my photo collection, and that entire folder is going to be my training data set. Okay, so once you've prepared the training data set, you'll want to make sure your environment is set up to run a notebook. To set up ArcGIS Pro with the ArcGIS Learn module, you'll need to install the Deep Learning Essentials package. In order to install a package, you'll need to clone your ArcGIS environment. Once that is done, you'll just be able to search for that Deep Learning Essentials package and install. And then that's basically all you need to do to set up when you're using the ArcGIS Learn module from a notebook in ArcGIS Pro. So next it's time to run the notebook and train the model. Before we look at the notebook, we're just going to look at a couple of the classes and methods that we're going to use in the notebook. First is the prepared data method, which takes the input training data and turns it into a data object that consists of training and validation data sets. Next, efficient det is a type of object detection model. And the efficient det class accepts the returned data object from the prepared data method, and then we'll create an efficient det object. The LR find method will identify the optimum learning rate for training the model. And then finally, the fit method will train the model while using the specified learning rate that we used in the previous step. And just a few more concepts for training a machine learning model. First is the backbone, which is the pre-configured neural network that'll be used in the architecture for training the new model. The batch size is going to refer to the number of training examples used in one iteration. Also, just a note that this setting does require some experimentation to get the model performance that you're looking for. The epoch refers to one complete pass through the entire training data set during the model training process. And then the learning rate is what's going to govern the pace at which an algorithm updates and overwrites old information during training. Also, keep in mind that there isn't a one-size-fits-all approach to training a machine learning model. But next up, we're going to open up the sample notebook and take a look at what it looks like. We won't have time to run the entire notebook today, but we will step through it and see what each step is, and then we'll also look at a notebook that's already been run that contains some of the output cells. Okay, so this notebook is available through this QR code, and we'll also include this again at the end of the session. We've included this intro in this notebook that explains the major steps. For now, we'll go ahead and skip that and go straight to the code cells. The first step is to set up the environment. In this case, that means importing OS and enabling the TensorFlow backend, because by default, ArcGIS Learn only works with the PyTorch backend. Next, we'll use prepared dataset to point our locally stored training data and create the training data object. So this is going to be dividing the training data up into training and validation sets. We're also setting the dataset type to Pascal VOC rectangles. The batch size will be 32, and the validation split percentage will be 0.2. So 20% of the data will be allocated to the validation set. So next up is the train the model section. In the first cell of this section, we're using the efficient det class to set the backbone. Next we'll be finding the optimal learning rate and then using the fit method to train the model based on that learning rate. I've set the number of epochs to 50. And then next up, we have show the results. This is going to display some of those images that were reserved for validation. So you'll be able to see the bounding box that was placed in the training data versus the bounding box that the model generates. And then we'll also see the average precision score and the plot losses. So this train the model section is the core of training the model. In the next section, we'll save the TF Lite model locally to your device and then do a test with a standalone test image. So this is what the notebook looks like before you run it. Next, we'll take a look at what it looks like after it's been run. Okay, so this notebook is run with a very reduced batch size and also a number of epochs. And that was in order to just quickly generate a few outputs to share today. In order to train a usable model, you'll want the batch size to be at 30 or closer to 32, and the number of epochs to be closer to 50. So this first output is showing the results of the model. Oops. This is showing a visualization of the learning rate of the model with the comparative loss. And so the optimum learning rate is identified here in red. You can also see the training losses and validation losses for each epoch that was run, as well as the time that it took to run the epoch. And then this next one, we have the results of the model. So the image on the left are images from the training data set. There's a faint red bounding box in the image on the left, and then these are going to be coming from the training data set, and then the image on the right is going to show the object that was identified by the model. In this case, the model didn't actually place a bounding box, and that's because the predictions made by the model didn't meet the probability threshold of 0.5 that we had set. So this is an indicator that we should go back, adjust the training parameters, and rerun the model. Next, we have the average precision for each object type. So this is going to be a more quantitative measure of the model's performance. And then finally, we have the graph of losses against the batches processed. So that's the feedback that we'll get after running the notebook that's going to allow you to gauge how well the model you just trained will perform. In our case, we know that the model wouldn't perform very well, but once we go back and adjust our training parameters with results that we're happy with, for example, once we see a bounding box here where we expect it to be, then we can incorporate that model into a survey and take it out into the field to test. And that next step is what Jim is going to show us in the next part.
Awesome, thanks Barbara. I'll just flick back over. Thanks for stepping us through all of that. This slide seeks to just kind of summarize a few of those key considerations, things that Barbara touched on, which are very important to take away from what the procedure that Barbara demoed for us. Firstly, that training a model is an iterative process. You're probably not going to get it right the first time. It takes a lot of tinkering with the batch size, the epochs, and the various input parameters, and also the training data set to get the desired accuracy that you want. You need lots of images. Barbara mentioned that we trained this manhole model that I'm going to show you in a second with 500 images. That's a very modest amount. You know, they were photos that we took around our office, just, you know, out there on an iPad. But I mean, you know, if you're making a really accurate model, you may be talking thousands, tens of thousands. The common object detection model I showed you earlier, as I mentioned, they used hundreds of thousands of images to train that model. So more images makes a better model, but the images have to be suitable for the use case. Basically, the images that you use in the training should be fairly consistent with the photos that you're going to take in the field. And you've got to take into consideration things like photo angle, lighting, distance to the object, and so on. Another key consideration is that data preparation takes a lot of human resources, time and effort, especially for labeling an object detection model. Barbara showed you the labeling of 3 objects in one image. Well, if you had 10,000 images, I mean, it's going to take you a very long time to get through that process. So that's a key consideration. You're going to have to dedicate someone's time to that process. You also need a lot of computing resources. We ran that model on our own laptops in that notebook, and it consistently fell over. Our laptops could handle it at, you know, at a certain low threshold, but you would really have to optimize your machine to run a model locally. The ArcGIS Notebooks option is therefore very appealing. You can specify a GPU sort of processing environment, and you're using a cloud computing service, so it's a lot faster, and it's obviously can handle these much larger models in a lot better. Obviously, there's the credit implication, but you've got to weigh that up against the time it's going to take you to do it on your own machine. Let me just forward on here. Okay, so once you've run the model, you'll get this output, which is a TF-Lite file and a .emd file. That's the metadata file. You just copy these to the media folder, and now you're ready to configure the questions in your survey. So Smart Assistant parameters are added to an image question in the XLS form, and the parameters go in the bind Esri parameters column, and you can add a whole bunch of parameters just separated by ampersand. So there's an example here. The name of our model is Manhole _ ED2. That's efficient det. I think that was the naming convention we used for that, efficient det 2. And we want the camera preview on, which means that we'll see the object detections live in the camera view. And this is just a quick example of then what you can do to extract that data from the object detections in the image question. So in this case, we're using pool data at EXIF to grab the JSON from the image description field. So that's just a tag in the image EXIF, but you get that whole JSON there. And then once you've got the EXIF into a question in your form, then you can pull out all of the attributes from that JSON file using pool data at JSON. So let's see our model in action. I pre-recorded this one. There's not a lot of manholes in here, so it was easier to do it on the street, actually in Melbourne, before I got on the plane to come over here. Here's a manhole inspection survey. In this case, we're taking a photo just of a single manhole. So you can see there, from a normal sort of standing position, it detected one round manhole. We've got a count of the manholes, and we've also got a select multiple question that's showing us what detections we get. Let's try that again in a different part of the street, a bit further down, where we've got 2 manholes, and here we have a round one and a square one. You can see it detects both of those, and it makes those selections in the select multiple and also shows me the count. We had 1 round one and round 1 square one. And here's an example of, I think what you're going to see here is the smart annotation feature in action. So same deal, out of the default annotation, you just get a bounding box and a label, which, you know, it's arguable how useful that is. But this next example shows you what you could do, again, very rudimentary, but what you could do with a custom palette. So here I've just chosen some very basic symbols, but I've used a round blue dot for the round one and a square, an orange square symbol for the square manhole. And so by using that custom palette, you can apply this custom symbology to the image. You can, of course, add more annotations to the image once you've got it there in the form. So there's those resources again, in case you missed them. Obviously, we've shared these slides, and as Barbara mentioned, I think you can get the links to these things anyway from the session details on the DevSummit website. And we've also got some learn more links and things in the slides here. When you get your copy of the slides, you can follow all these links to learn more. So that kind of concludes our section on making TensorFlow light models for smart assistants in the field app. I'm trying to get the terminology right here because we're using that assistance terminology quite a bit. And this is the other thing that I wanted to show you, which we demoed in the Road Ahead yesterday. Separate to what you can do in the field app, we're now switching gears to what's possible in the web. So this is pure research and development at the moment. It's still very, very early days, but we're hoping at some point we may be able to bring this into the web designer. We're calling it enhanced calculations with AI, effectively using generative AI to extract information from a photo that you take in the survey. With this feature, there's no need to use complicated syntax. You literally just ask for what you want from the photo in natural language. And I've given a couple of examples there, and we're going to see it in action shortly. This demo is pre-recorded, but it was recorded live, you can trust me. The only thing I've adjusted is the zooming, just so you can kind of see what's going on. So here's the Survey123 web designer, and we're making a survey here to capture traffic violations. And from a photo of a car, we want to be able to pick up the license plate, its color, and the make of the car. So this calculation editor is what you're used to seeing in the web designer. The only difference is for the custom property, we get a text box where we can just enter a natural language prompt like you would with ChatGPT, and you just ask the AI what you want from the image. So you can see here for the vehicle color, I'm asking it to output the color of the vehicle. And I think we've got a make question as well, so we'll add that as well. And I want to select a custom property from the vehicle photo, and in this case, give me the make of the vehicle. And now we're ready to go, so I'll publish this survey and we'll take it for a spin. So you can see there we're looking at license plate, color, and make. So these are things that it's going to pick up from the photo. It's not just detecting, there's the photo of the car that we're gonna catch speeding, I think, in this case. It's a nice car. And you can see I'll enter the location of the traffic violation, the violation type, and then we add the image of the car into the survey. You can see it's calculating and the model's thinking about it, and then it comes back with the details, the license plate 7MCY820, it's a white Tesla, and if we look at the car, again, you can see it got it spot on. We actually tested this yesterday afternoon. My colleague Brett was putting it through his paces. It was even able to work out the make of cars when it couldn't even see the badge or the brand name of the car. From obscure angles, it was able to tell us with some degree of certainty what the car was. It's really, really cool. Okay, so I think we've got time. I might show you another demo. It's a much shorter demo, but of a slightly different use case. Or maybe I don't have it in here. I don't have it in here, but I can show you some other time. Please come and ask us. We have another demo with water meters, which is a much more kind of practical use case for this, I guess, where we had a customer who wants this kind of technology because their inspectors are going out in the field, they're taking a photo of, you know, a water meter at a commercial property or at a house, and you have the little readout there with the number of litres or gallons, should I say, that have been through the water meter, and it can pick up the value on the water meter, which is really cool. It's a huge time-saving feature, of course. Okay, so that was the sneak peek of calculations using AI in the web designer. Stay tuned for more information about that. Obviously, as I say, it's still very much in the works. We're getting towards the end of the DevSummit. We actually still have 2 Survey123 related sessions to go. Barbara and Zach will be presenting Survey123 for Python developers in a very short amount of time, just down the hall here. And on Friday morning, if anyone's keen for it, at 8:30, Calvin and Nan will be presenting Getting Started with the JavaScript API. Lots of resources available for you for Survey123 and videos, and of course, please join us on Esri Community. We're very active there. We love to answer your questions and get involved, and we love seeing what you guys are working on. And the obligatory feedback slide, we love seeing this feedback as well. Please let us know how we went with this session. You should be able to see that in the Events app. Connect with us on social, Esri DevSummit 2024. And finally, the final slide. Thanks so much for your attendance. Thanks for watching. And if you've got any questions, we'd love to hear them.
Yeah, right here.
Is there a repository of pre-trained models available, or?
That's a really good question. There are lots of, I'm not sure of a repository that, holds multiple models in one, but you can certainly find open source models. That common object detection model is one that we often fall back on, and we use it for demos and those sorts of things. But there are plenty out there that you can look for and take for a spin. One thing that you may come up against is the format that they're in. TensorFlow Lite, as we mentioned, is just one model format, but you can, PyTorch and Onyx, and there are lots of other formats. So finding models that are specific, that can specifically be leveraged in the field app might be a little bit tricky. Barbara, I don't know if you have any experience with finding libraries of models.
Yeah, I don't know specifically of any, but yeah. I think you covered it.
Yeah, the TensorFlow Lite has like a TensorFlow hub, I think they call it, and it's a site where they have a lot of like test models in there as well. I remember in our early days when we were trying to get this feature up and running, we did utilize quite a few model files from that TensorFlow hub. So perhaps check that out and see how you go. Of course, we like to kind of stress that the model that you want to use, obviously, it's got to be right for the photos that you're taking in the field, because otherwise, you could have the most accurate model in the world, but if you go out in the field to take the photos that you want to take, it may not be accurate for that use case. So,
Okay, thank you.
Hi.
I'm not sure if you mentioned this because I missed the first half, but similar to OpenCV, you have to have your same resolution considering the photos. They all have to be the same, and you have to consider standardization of the EXIF data. Is that the same for here, for yours?
Sorry.
You're cutting the resolution. So in OpenCV, you have to have the same resolution for all the photos.
Right.
And the EXIF data has to be standard. Is that the same for this model?
Do you mean for the training data or for the data that you?
For the data mining. So if you're going.
That's a good question. I don't think that the images have to be of the same dimensions and resolution.
Yeah.
That model that we made had a combination of photos taken from a bunch of different devices, and it seemed to handle it no problem. Effectively, it's just doing some sort of pattern matching. So, it's chopping out that bounding box and saying, hey, the pixels inside this bounding box represent object A, object B. So. That's a really good question. I don't know if we've actually even considered that. It would be really cool. I think there are models that can process video feeds. We've never even tried it. Definitely something for us to consider for the future, I think. Thanks for your question. Hello.
Hi, I have the microphone. I have 2 quick questions, I think. One is, will the smart redaction be available in the web form in the future, the blurring?
That's a good question. I can't remember if we've had conversations about this or not.
Yeah.
Technically, it could be possible because it could use something other than the built-in redaction currently uses Google ML-Kit. Or you can also specify if you really want to use the Apple Vision API on iOS and iPadOS devices. It doesn't currently run in the web app, but we probably have to explore using some other sort of online API service to do that face redaction. So it's not beyond the realms of possibility. I'm not too sure that we've had a whole lot of demand for it yet, but I'd love to hear more about
We have
your
an
use
immediate
case.
use case. I can tell you about it after.
Great.
And then my other question was for the annotation. Is there an option to offset it so that it's not actually like covering up the thing that you're annotating?
Yes, you can do that. In the palette, the XLS palette, as we like to call it, which was a name that likes to kind of mirror the XLS form terminology. You can get quite sophisticated with the way that you set up the symbology, and that includes symbol offset. Yes.
Thank you.
No problem. Thanks for your question. Hello.
I think I'm good. Hi. As far as the TF Lite, is there anything special going on with the ArcGIS Learn module, or if we don't have enterprise, can we just use our own TF Lite models that we create ourselves?
Yeah, you should be able to. It doesn't matter if the TF Lite model was created with the ArcGIS Learn module. Yeah.
Yep, you could use any TF Lite model. You might. The ArcGIS.learn module makes that EMD file for you, which contains the metadata, the key bits in there, in that metadata. I mean, it's got stuff in there about model format and other things, but the key bits of information are regarding the classes. Technically, actually, Survey123 will work without the EMD file. You can just use a text file that has like a list of the classes. So that shouldn't be a blocker for you. If you've got a TF Lite file and the classes are just in a text file, it will still work.
As I know, the EMD file is proprietary or required, so.
Yep, no, you can certainly make it work in the Survey123 field app without it. Yep.
Hello.
Hello.
Are there text recognition capabilities with the object detection?
Text recognition, or OCR, is something different. So OCR technologies are different to what's happening in object detection or image classification because they have other logic to, I guess, interpolate fonts and scripts and those sorts of things. I'm not aware of a TensorFlow Lite model that kind of combines the two technologies. It's almost a separate service. Having said that, maybe there are ways to train an OCR model. One thing that we had looked at, the demo that I showed you at the end that sort of uses the generative AI to detect things in that photo of a car, is what they call a large multimodal model, another LMM abbreviation, which is a combination of those technologies because it's doing generative AI, but it's also doing like image understanding. There's some sort of OCR going on in there as well. It's a bit of a mixture. But as far as the TensorFlow Lite object detection models go, I don't know if there is a way to, do character recognition.
Yep, up here.
Question. As with the models used in the Survey123, can you use more than one model in the one survey? Let's say in the detection, maybe I have a fire hydrant model or a training file versus a manual. Can I combine both in the one survey to do for a particular department?
Yes, you can. That is possible to have multiple on the same image, right? Yes.
Multiple models and then multiple types of objects within one model, whichever way is easier for you to do it.
Hello.
Hello again.
Is there a way to access the objects that have been detected and kind of filter the images that are showing up, let's say in your report template, after you use this model?
Yeah, if you do something similar to what Jim was demoing, where you extract the object type, you could filter your report based on that extracted object type. That would be one approach that would be good.
Yeah, one cool use case we've seen, not for reporting, but for using the image, the information from the object detections, is to actually use that as a constraint. So, you may put a constraint in the form to say, like, take a photo of X, Y, and Z, and the object detections are made when you take that photo, and you could set up a constraint to say, hang on a minute, the photo doesn't contain a fire hydrant, or so you can't submit this until you take the photo again, and so that's a useful application for the smart attributes.
Can you combine the smart detection with also a manual detection? For example, maybe the training file would not detect a particular object, doesn't matter how much you take that picture. Is there a possibility or a way that you can manually add that data to your data set?
That's a good question.
Yeah.
I think what you would probably rely on then is just the questions in the form. If I'm understanding you correctly, you take a photo, for whatever reason the model doesn't do a great job of detecting it. Yes. But if you allow the user then to kind of specify, I guess you could design your form in such a way that they then have an option to say, hey, look, the photo does actually contain X, Y, and Z. I just missed it with the model. As far as getting that information into the image EXIF goes, that may be a little bit more complicated. We don't currently have a way to kind of draw the bounding boxes on and have that get written to the EXIF manually. The closest thing we have is the redaction editor, which allows you to add your own boxes and move them around. But that's purely for the purposes of redaction, not smart attributes. Yeah. Anyone else?
I've used oriented imagery some, and I'm wondering if it's possible to combine this with oriented imagery so that it'll drop a point on the ground where it spots a manhole in your image, if you have sufficient EXIF data.
I have not experimented with that specifically, but it does sound like, it might be possible to use the EXIF data in that way. Yeah, I don't know.
Yeah, I'm not sure. Yeah, it's a really interesting question because I'm not too sure exactly how it would maybe geolocate the object in the image, but it would at least be able to maybe there's a way to kind of get the center of the bounding box or something and say, like, this is the point in which that object the object exists at this point in the photo. How that would translate into the oriented imagery viewer, and I'm not sure.
From what I've seen, is like it drops the points in the image where you're taking photos from, so you theoretically should be able to also do that. It'd be so nice, because then you could do like drive-by images.
It'd be really cool. Yeah, it is a really great idea. Yeah, thank you.
I don't know about Survey123's capabilities, but you could make a custom app and use GDAL libraries in order to do something like that, as well as OCR. I don't know if you could build it in, but does the deep learning library, does that have OCR and Python Magic?
That's a good question.
That's a good question.
Yeah, I haven't seen it, but.
You could build your own in theory then with Python, right?
Yes, yep, it's a good point. Yeah, OCR and the API I'm not too sure about. But yeah, this idea for oriented imagery just does sound like a new a new avenue for us to explore for sure. Yep. Cool. There's no further questions. Thank you, everyone. It was great to see you all here, and yeah, thanks for the great input and feedback.
Yep, thank you.
Cheers.